let's continue with electronic configuration for elements. So I've gone ahead and put the different subshells on the periodic table for us. So these two columns are the S subshell. These 6 columns over here are the P subshell. Okay, the S subshell has one orbital, which is one pair of electrons. The P subshell has 3 orbitals, or that's 3 pairs of electrons, so 6 electrons. 1, 2, 3, 4, 5, 6. The D subshell has 5 orbitals, which are pairs of electrons again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the F subshell has 7 orbitals, 14 electrons. Okay, let's start assigning some electronic configuration. So for cadmium, cadmium is right here on the periodic table. It's got, well, the way you do this is you count up to cadmium. So it's got both of these 1s electrons, right? So we would write 1s2. It's got both of the 2s electrons, so 2s2. It's got 6 of the 2p electrons, 2p6. It's got both of the 3s electrons, 3s2. You guys might be fast forwarding this now. It's got all 6 of the 3p electrons, 3p6. Okay, it's got the 4s electrons. Okay, it's got the 3d electrons. It's got all 6 of the 4p electrons. It's got 2 of the 5. It's got both of the 5s electrons, and it's got 10 of the 4d electrons. Okay, that was a lot to write. There's a shorthand way of writing this. So if you notice krypton's up here, it's the noble gas right before cadmium. Okay, the way you can write cadmium shorthand is say, okay, it's got krypton's electronic configuration. And it's also got, in addition to krypton's electronic configuration, it's got the 5s and the 4d. So we could say 5s2, 4d, 10. That's the shorthand way of writing it. Okay, we can also fill out an orbital diagram for cadmium. So if we look at cadmium down here, we can show these electrons visually. And this is kind of a long-winded process, so I'll try to do my best to keep it short. But it's got both of the 1s electrons, and those fill just like that, right? It's got both of the 2s electrons, spin up, spin down. Remember when assigning the 2p electrons, they fill one at a time. So it's got all 6 of them, but they fill just like that. Hund's rule, right? This minimizes the electron-electron repulsion. So filling one at a time minimizes electron-electron repulsion. Okay, it's got the 3s electrons. It's got all 6 of the 3p electrons. And again, Hund's rule, this minimizes electron-electron repulsion. Okay, it's got the 4s electrons. Okay, I'm going to need some space over here for the next one. So it's got the 3d electrons. Hund's rule again, you guys probably already saying, I'm going to say it, minimizes electron-electron repulsion. That's why they fill like this, okay? It's got the 4p electrons. That's not the best P I've ever drawn there. Well, let's try that again. Let's see if I can draw, let's see if I can just write my letters today, let alone teach some chemistry. Okay. All right, 4p, then 5s, and then 4d. Again, Hund's rule must be followed. Okay, that is the orbital diagram for cadmium. Right? I'll let you continue filling out the rest of these. So lanthanum, I will say there's one trick to lanthanum. Put lanthanum here on your notes. Lanthanum is down here actually. So if you look at the periodic table, you'll find, and I've expanded this periodic table into wide view so we can see this better. Let me first collapse it so you guys can see that. Okay, lanthanum starts the lanthanide series. So this is after barium. Instead of going, so we've got 6s, instead of going to 5d, we go down to the 4f, right? So this is a lower energy state than the 5d electron. So keep that in mind whenever you start lanthanum. But again, if you go to ptable.com, press wide, this will make your life easier. You don't get this kind of periodic table on the AP exam. You get the collapsed version. So I'll let you fill those out. And if you have questions, if you've done it right, just see me in class, and I'll see you in the next video.